Okay, this is the last lesson for Physical Behavior of Matter, Lesson 8. And the objective today is to talk about Dalton's Law of Partial Pressures. Now, I want to state out front that Dalton's Law of Partial Pressures is not tested on the regions. I will not use it as a formal question on my test. You can probably look for it as a bonus question. But it's still important that you understand the concept. And I'm going to introduce one new formula that you are not held responsible for at this level, but will be using if you take the next level. So, Dalton's Law of Partial Pressure tells us that in a mixture of gases, the total pressure is equal to the sum of the partial pressures of each gas component. So the total pressure is equal to pressure 1 plus pressure 2 plus pressure 3. Pretty simple law. And these individual pressures could represent different gases: nitrogen, oxygen, helium. Okay? So let's just look at a very simple basic problem. It says the total pressure of 3 gas components in a mixture is 550 torr. Remember, torr is just another unit of pressure, just like ATM, kPa, or millimeters of mercury. If the pressure of gas A is 200 torr and the pressure of gas B is 75 torr, what is the partial pressure of C? So we don't know what C is. I'm going to rewrite the equation using the letters. So I have P total equal to PA plus PB plus PC. Okay? Now remember I tell you all the time, when you're trying to isolate a variable, you have to do the opposite. Okay? So if I've added these, I need to subtract them. So A plus B, okay, we're going to subtract from both sides. So minus PA plus PB minus PA plus PB. So these cancel. And I'm left with PC, the pressure of C, is equal to the P total minus PA plus PB. So now this makes it very easy to solve. Our total pressure was 500 torr minus the pressure of A, which is 200, plus the pressure of B, which is 75. So really 500 minus 275, and PC is equal to 275. And that would be in torr. Easy enough. Let's look at a second problem. A mixture of oxygen, nitrogen, and hydrogen gases exerts a total pressure of 74 kPa. So there's my P total. The partial pressure of oxygen is 20. So oxygen is 20 kPa, nitrogen is 40 kPa. What is the partial pressure of hydrogen? So let's rewrite our formula again. P total equals the P of oxygen plus the P of nitrogen plus the P of hydrogen. And we're trying to find hydrogen. So we're going to subtract from both sides. We'll be left with the P of hydrogen is equal to P total minus the P of oxygen plus the P of nitrogen. Our P total is 74 minus our PO is 20 plus nitrogen is 40. So basically 74 minus 60. So the pressure of my hydrogen is 14 kPa. So that's the formula, using it at its easiest capacity. Now I'm going to introduce a new formula. It says a cylinder is filled with 2 moles of nitrogen, 3 moles of argon, and 5 moles of helium. It's at STP. So STP means standard temperature is equal to 273 Kelvin and pressure is equal to 1 ATM or 101.3 kPa, but I'll explain in a moment while we're using ATM. And they want to know the partial pressure of argon. Well, there's a couple different things going on. They're asking about pressure, but they gave me moles. So I have to introduce a new formula, and it's called PV equals nRT. At the college level, we call it PervNert, and there's a whole big rap song that goes with it. So if you take that class, you'll get to hear it. So P is my pressure, and it must be an ATM, which is why I chose 1 ATM for the standard. Volume is always in liters. N is moles. Moles, so like given mass divided by gram formula mass. R is a gas law constant equal to 0.0821 liters dot atmosphere mole dot Kelvin. And T is my temperature, and that must be always in Kelvin. Okay, so this is a new formula. You have to make sure that you have agreement of units. So if they gave you milliliters, you'd have to have liters. If they gave you grams, you'd have to change it to moles. If they gave you Celsius, you'd have to change it to Kelvin, because we need to have agreement of units. So the first thing that we have to do, before we can even find the partial pressure of argon, we have to know, using this formula, what the total volume of all these three gases are. My pressure is 1 ATM. My volume, I don't know. My moles, or my total moles, 2 plus 3 is 5, plus 5 is 10 moles of gas. I have my gas constant. And my temperature, we said, was standard 273. So I'm solving for V, okay? So in this case, ATM is 1. All I have to do is multiply 10 times the gas law constant times 273, and I get a total volume of 224.133 liters. So that's my total volume. That's needed. Now I just want the partial pressure of argon. So I get to use the same formula again. Let me change ink. We're going to use PV equals nRT again, except for this time we're just interested in argon, which has 3 moles of gas. So we're going to use 3 for 3 moles times our gas law constant. The temperature hasn't changed. I now know my volume, which is 224.133, and we don't know P. So that's very easy. If we divide both sides by 224.133, these cancel, and I'm left with P equals. So in my calculator, I'm going to want to do parenthesis 3 times 0.0821 times 273, end of parenthesis, divided by 224.133, and I get 0.3 ATM. So that would be my complete answer, the partial pressure of argon gas. Alright, let's just do one more of those for practice. If 4 moles of oxygen, 3 moles of hydrogen, and 1 mole of nitrogen are combined in a closed container at standard pressure, and this should say, and temperature, what is the partial pressure of hydrogen? So they want the partial pressure of hydrogen. So we're going to start with PV equals nRT. Remember, the first thing that we need to do is find the volume. Standard pressure is 1 ATM. Standard temperature is 273 Kelvin. So we have 1 ATM times V. Our total moles, 4 and 3 is 7 and 1 is 8, times our gas law constant, times our temperature of 273 Kelvin. So our volume is simply 8 times 0.0821 times 273, which gives us a volume of 179.3 liters. Remember, this is in liters. We're not done yet. We now need to find the partial pressure of hydrogen only. So we don't know P. We know our V is 179.3 liters. We know our moles for hydrogen is 3. Our gas law constant is 0.0821, and our temperature is 273. So we're going to divide both sides by 179.3, and I get a pressure equal to 0.375 atm, or approximately 0.38 atm, and that is for hydrogen. Now, I want to just show you, you noticed how I didn't write all the units when I was solving the problem, but I want to show you that the units work out. So let's take this original PV equals nRT, okay? And we know that our pressure is in atmospheres and our volume is in liters, and this is moles, and R is liters dot atmosphere mole dot Kelvin, big units there, and temperature is in Kelvin. So you can see that Kelvin cancels with Kelvin, mole cancels with mole, liter cancels with liter, okay? And the atmosphere does not cancel with this because this was what we were trying to find. P is in atmospheres, okay? So we were trying to find that. So our pressure was left in atmospheres. We have one last thing to just review very quickly, and that is density. You are all familiar with density from earth science, the quantity of matter in a given unit of time. It equals mass divided by volume. We can find typical densities in table S for all of the elements that are listed on the periodic table. Please don't forget about that. Regents loves to ask questions. Take a look at the two boxes below. Each has the same volume. If each ball has the same mass, which box would weigh more and why? Well, hopefully you told me this one, and that's because there are more balls per unit volume. So therefore, this is going to have more weight. And the last explanation that they gave there was the box that has more balls has more mass per unit volume. This is a property called density. The density of a material helps to distinguish it from other materials. Since mass is usually expressed in grams and volume in cubic centimeters, density is usually expressed in grams per cubic centimeter. However, you will often see it expressed as grams per milliliter as well. That is it for our unit. Again, Dalton's law will only exist in the bonus capacity for this test. Please look for a review PowerPoint lesson that I will be posting hopefully on Friday for you to look at over the weekend, and you should be working on the practice test. See you next class.